Welcome back to our channel. This remains your online solution to all your problems in chemistry, the Kenyan teacher. In today's video, it is our pleasure to take you through the testing of the periodic table. This is K.C.S.E. Chemistry Paper 2 for the year 2024. Question number 1. Figure 1 shows part of the periodic table of elements. We are informed that the letters do not represent the actual symbols of the elements. So the examiner gave us letters A to P in different periods and groups of the periodic table. So we want to study the grid and answer the questions that follow. Beginning with question A, which informed us that element Q belongs to period 5 and group 6. So we want to place the element in the correct position in the grid in figure 1 for 1 mark. So dear candidate, we know very well that the grid that represents the periodic table is made of horizontal rows that we call periods. So here is period 1 that goes across, period 2, period 3, period 4, period 5, and a complete table has got 6 of such periods. Then we have the vertical columns that represent groups. So here we have group 1 running downwards, group 2, then there is a separation here that consists of 10 groups that is occupied by transition elements. So this is a separation between group 2 and 3. Groups are usually represented by Roman capital letters. So we have 4, 5, 6, 7, and then there is group 8, or we call it group O. So we are informed that element Q belongs to period 5, group 6. So what a candidate needed to have done is to simply follow period 5 to the right, and then follow group 6 going down, and then element Q would be at the intersection of the two. So this is where Q would have been for 1 mark. Then we move to part B. Part B informed us, or rather demanded that we consider ions of elements J, K, and M. And we are told that J forms an ion of 2 minus, K an ion of 1 minus, and M an ion of 1 plus. I would want us to go back to the grid and see where the elements are before they form the ions. So J is here, and we needed to know its atomic number. So we simply count period-wise from here. And we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So element J would be atomic number 16, whose normal configuration would have been 2, 8, 6. But we are told it forms an ion of J2-, meaning it accepts 2 extra electrons. So the new configuration would be 288. Now, moving to K is here just after J. So that would mean it is atomic number 17. Normal configuration of the element before forming an ion would have been 287. But to form an ion of K1-, we would therefore means we are gaining 1 extra electron, and the configuration would also be 288. To M, this is 17, 18. M now is atomic number 19. 19 would have a configuration of 2881, but it is forming a cation with a charge of 1 positive. So that means we are losing the outer electron to form the ion. For that reason, our ion M+ would also have a configuration of 288. So, to the first question for part B, after considering the elements and their ions like we've done, we were then told to write the electron configuration for each. And as we've agreed, all of them would have a configuration of 288, depending on how they form the ions. It is 2 marks, so all 3 correct would award 2 marks. 2 correct would be 1 mark, and only 1 correct would earn ourselves a half a mark. Part 2 of B, we were told to, among the 3 ions that are given here, we were to select one with the largest ionic radius. So this would mean that we get back to the atomic numbers of the elements. J, number 16, K, number 17, and M, number 19. So these numbers represent the number of electrons on the energy levels, but they also represent number of protons in the nucleus. So we realize M has the largest number of protons. It has the strongest nuclear charge, and J has the least or the weakest because it has the lowest number of protons. So the largest ion would be that with the weakest nuclear charge, and therefore the answer here would have been J2-. That is the ion with the largest ionic radius. Then we would go ahead and give a reason. There are quite a number of reasons that we would go for. The first one is that it has the lowest nuclear charge, just as I have explained. This could be substituted with it has the least number of protons for the next half, giving us a total of 2. At this point, we now move on to part C of question 1. Part C demanded that we complete the table here, that is table 1, by filling in the formula of the compound formed and then the type of bond between the elements A and B and then G and C. So let's start by elements A and B. We get back to the grid and see where these elements are. Element A is here, group 1. So it has a valency of 1. Element B is in group 5, so it will have a valency of 3. For those who may find this difficult of how to obtain valencies from the groups where the elements belong, you can do a quick electron arrangement for the 2 elements based on their atomic numbers, where element A would be atomic number 1, 2, 3. That gives it a configuration of 2, 1. And then we have element B, 4, 5, 6, 7. That gives it a configuration of 2, 5. So from here we can see A has a valency of 1 and B has a valency of 3. So when we shall be writing the formula of the compound, we will have A, B, valency 1 and valency 3. And then, as you know, they interchange. So the formula becomes A3B. So this is what we shall copy back to the space that was left for the question. But before we do so, we realize A is a metallic element because it forms ions, or it becomes stable through loss of outer electrons, while B is a non-metallic atom or element because it forms ions through gain of extra electrons. So the kind of bond or the type of bond that we shall form is obviously ionic, or what we normally call electrovalent. So with that information, we now get back to table 1 and put in our correct answers. Formula of the compound, formed between A and B, we have agreed is A3B. One thing that candidates should also know is that as you write this formula, please, we usually start with the more metallic element. I know some of you might be thinking of writing Ba3. This would not be acceptable because ordinarily we write formulae of compounds beginning with the more metallic element, the one that is on the left of the periodic table, then followed by the one that is on the right. So this would be the correct formula, but we can do the actual formula, which becomes lithium nitride. Type of bond, we've said ionic, because A is metallic and B is non-metallic. So there would be complete transfer of electrons, and therefore we form ionic bond, or what we call electrovalent bond. So we move to G and C. But before we do so, on the marking, it was 1.5 mark. So the formula had 1 whole mark and the type of bond a 0.5 mark. Let's now get back to our table or our grid once more and have a look at the positioning of elements G and C. Now, G is group 4. So, the valency of G is obviously 4. C is group 7, and the valency would be 1. So as we do the interchange of valencies, we realize that the formula becomes GC4. We could convert this into the actual G is silicon and C is fluorine. So silicon tetrafluoride. Now, both G and C are non-metals. So the type of bond that we expect here is now covalent. Again, as you write the formula, we start with the more metallic element of the two, the one which is on the left. We now get back to our table 1 and put in our correct answers based on the discussion that we have just heard. Formula of compound G-C-4. You could go for the actual formula of the compound silicon tetrafluoride. The bond that we expect, because both are non-metallic atoms, is covalent. Again, 1 mark for the formula, a half for the type of bond. Part D expected us to explain some chemical observations that we see in the elements that are there in the periodic table. Beginning with Roman 1, we want to explain why the electrical conductivity of F is higher than that of E. So once again, we need to refer back to our grid and see where F and E are. So here is our grid. Element E is here. Now, for us to answer that question that we just looked at, it may be good that we know the actual identity of E and F. So we shall start from the beginning to see the atomic numbers of the two. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So E is atomic number 12, and therefore it is magnesium. F is atomic number 13, aluminium. So candidates, the examiner is simply asking us to explain why aluminium has a higher conductivity than E, of course, electrical conductivity. And you can relate that they are all in period 3, and they are all metals. The conductivity of a metal depends on the number of delocalized electrons. F has 3 and E has 2. We now go back to the space that was left for the explanation and put in this observation. So we've agreed that F surely has a higher electrical conductivity than E. And this is because F has more delocalized electrons. Instead of talking of delocalized electrons, we can talk of mobile electrons. And a candidate also would go ahead and tell us that F has 3 delocalized electrons while E has 2. Good enough for 1 mark. So to Roman 2, we were told to explain why element M is a stronger reducing agent than D. So once again, we refer back to our grid and see where M and D are located. So M and D are right here. They are all in group 1. They are all alkali metals. But we are told that M is a stronger reducing agent than D. So these are metals, and we say generally that metals are strong reducing agents, but M is stronger. So this is all about ease of loss of electrons. M has a larger atomic radius, and therefore it easily loses its outer electrons more than D. And now that makes it to be a stronger reducing agent. In Form 4, remember, we defined redox in terms of electron transfer. So in this case, a reducing agent where M is a stronger one normally gets oxidized in reactions, and oxidation we defined as loss of electrons. So the more easily a metal loses electrons, the stronger the reducing agent it is. With this candid discussion, now we get back to the space for the answer and put it down as discussed. So we've agreed here that M loses electrons more easily than D. So loss of electrons is oxidation, and that is what happens to a reducing agent. And we've said the more easily a reducing agent can lose electrons, the stronger the reducing agent it is. Now, other than this, the other options to this question would mean, or would be that M is more electropositive. That would also be a correct answer. We can also say that M has a lower ionization energy. Any of those would be correct explanation. So we finally end the video by looking at part 3 of section D, where we were told again to explain why the melting point of H is lower than that of N. We get back to the grid and see where H and N are. So here we are. H and N are here. Unfortunately, N was not part of the first 20 elements, so we could not be able to relate it to an element that we know. So we realize that H and N are non-metallic atoms. So they form what we call molecules. And we have agreed in class that the bigger the atom in a molecule, the stronger the van der Waals forces, or the intermolecular forces of attraction. So we expect the intermolecular forces of attraction in molecules of N to be stronger than those of H, simply because of the size of the atoms that make up the molecule. With this piece of information, we finally get back to the space and answer our question as expected. So here, the candidates were simply to tell us that H has fewer, or we will still accept weaker or less intermolecular forces, what we always call van der Waals forces. And as we have discussed, this is based on the size of the atoms that make up their molecules. That would earn us the last 1 mark, and that will be the end of our video, where we have reviewed the testing of the periodic table for the year 2024. Don't forget that this is one of the sections that never misses in paper 2 every other year. We sum it up as periodicity of elements. And in that, we have the periodic table being tested, the atomic structure being tested, period 3 elements being tested, chemical families being tested, and we have structure and bonding. We wish our candidates the best as they expect to have a similar questions during the 2025 KCSE. Keep it locked right here for more of such very insightful reviews.